Alright guys, back here for day 2 of our vlog video series. As a recap, yesterday we got some material cut up, dial indicated it on my little benchtop lathe here, and then started to machine the face and the outside diameter of it. And if you recall, I said this is going to end up being a spacer for that exoskeleton that I'm going to be building. So I can't really put that on camera, but I can show you the spacer at least. So what I've gone ahead and done is, just quickly taken some measurements, and I can show you those pretty easily. So the length of the spacer is going to have to be 375 thousandths or 3/8 long, 375 thousandths in diameter or 3/8, right? And then the hole through the middle, so this is going to be, a spacer on kind of an axle. The hole through the middle is going to be 187.5 thousandths. So, I'm going to machine this pretty slowly on here. So probably what I'll end up doing is doing kind of like a time lapse of me machining this so that you can see it. But before really I, get into that, what I'm going to be using to make sure that I hit my measurements, I'm going to be using a micrometer to measure the outside diameter of this cylinder. And I'm going to be using a dial caliper to measure the length of it, right? So the first thing that I kind of need to do is get it all roughed out. And I'm going to machine it long so that I can go on my bandsaw, cut it off, flip it around, re-indicate it on the chuck, and then machine the other face on the other side down to exactly 0.375 in length. So I'll end up using the dial caliper and the micrometer in the process. I'll try to give you guys a shot of that, or kind of an overview of the process that I use to use those. I know that we went over that in the beginning of the school year, but I thought this was a good opportunity to review those two tools and that kind of skill, because obviously in this application it really matters. I don't have any way to measure on the machine like we do at the school, where our handles have a dial face on them that we could do it manually, right? Like kind of analog. But we also have that digital readout screen that's kind of up and behind that really helps us measure and accurately machine our parts. Well, I don't have that on this little thing, so I have to take a little bit off at a time, measure it, and then take a little bit more off if I need to. So that's the way that I'm going to achieve my final dimensions on this, is using the the dial caliper and the micrometer. So I'm going to change camera angles here, probably do a little bit of time-lapse video so this doesn't end up being like a half hour long. So let me set you guys back up and I'll show you what we're going to work on. Okay, so I've brought you guys back here. I've done quite a bit of material removal here. So let me check our dimensions here. So we're shooting again for 375 thousandths on outside diameter. And currently I've got 375, 95, about 397. So I've got about 397 thousandths on this outside diameter here. And the goal obviously is 375, so I got to take a little bit more off. But between what you saw in the time lapse and what I just showed you here, checking periodically with the micrometer on that dimension is super important. And I'll try to get a little close-up shot once I get it to final dimension. I'll try to get a close-up shot of that micrometer so that I can show you guys how to take that reading once again. So that probably took a couple thousandths off, but we'll just to err on the safe side, we're going to just keep creeping up on this measurement, trying to hit 375 thousandths right on the money. So I've got about 6.5 thousandths to take off before I hit that 375. So let's see if we can hit it. Gonna take a real light cut. We're at 376.5 right now. I might be able to take that off there, but in this application, plus or minus 2 thou is perfectly fine. So we're about 376.5 is where we're at there. Okay, so I'm going to try to reset the camera here to give you a little bit different angle so that I can show you how to read this mic in a little bit better detail. All right, I brought you guys back, change up the angle a little bit here. And what we're looking at is, this micrometer and how you guys measure it. So we've got, if I rotate this thimble, right, what we're going to look at first is the main scale. And if I take this to 0 on our secondary scale here, lining up with that center line, that's exactly 300 thousandths right there, right? So 0.3. Now as I rotate this is going to reveal 25 thousandths lines. So we'll go back this way. There's 0.325. There's 0.35. And there's 0.375. Okay, so that was what we were shooting for, is 375 thousandths. But when I measured the diameter of that, we were right about there. So we were another 1,000th and about a half a thou over. So we were at about 376.5 thousandths, which again on this little old machine is pretty good. Okay, so the first thing we're going to do is we're going to read the main scale for 100 thousandths of an inch. So I'll kind of reset this and show you that one more time. So 300 thousandths, 325, 350, 375, and again when I measured it we were at 376.5. Okay, so what you're going to end up doing is in the comment section on Google Classroom, you're going to name a couple takeaways, right? So this could be one of them. I'm going to go slice up the material in length, and then we'll flip it around and face it, and then probably drilling the hole through the center is going to be another day. So here's a micrometer. This is a 0 to 1 inch micrometer, so no bigger than 1 inch. All right. I'm going to bring you guys back after I've gotten the piece cut. All right, so as you can see, I've cut that little spacer off, sliced it off on the bandsaw. I'm gonna have to face this down, right? It's too long. It ends up being 375 thousandths in length. Currently, okay, here's our dial calipers. Currently is 534 thousandths in length. Okay, so where I'm getting that from, the first thing I'm going to do is look at the main scale and look for whole inches. Well, obviously I don't have any whole inches. This is smaller than whole inch. So I'm going to look at 100 thousandths of an inch. So 1, 2, 3, 4, 500 thousandths of an inch, or half inch, right? Then I'm going to come over to the dial. 0, 10, 20, 30, 40 are 10 thousandths of an inch. Okay, so there's 30 thousandths, so 530 thousandths. And then I'm going to come and look at the needle, and that is on the 34, about, maybe a little bit shy of that, but for this purpose, we'll call it 34. So it's 534 thousandths in length, right? So if we did some quick math, we can figure out exactly how much, from our 375 thousandths in length to take off of this face after I've cut it on the bandsaw. So probably off camera, I'll get this thing dialed in again with a dial indicator, get it running true, and then tomorrow I'll bring you guys back. We'll face this off and drill a hole through the center to get our 187 and a half thousandths in diameter, this through bore hole. Okay, so again, in the comments of Google Classroom, make a couple points. I'll put the question that I'm going to be asking you guys in there as well, but make a couple points, right? You saw me turning on the lathe, taking small amounts off, creeping up to my final dimension, using the micrometer to measure the diameter, and using the dial caliper to measure the length. Subtract those two, and that tells me how much I have left to take off of the length of this. Okay, there are plenty of parts on some of the projects we're working on where this exact process should be used, right? Either the air engine, the air cannon, anything in any of our classes that we work on, that process more than likely will work. Okay, we'll catch you later, guys.